So for today, we're going to work on Unit 8.5. Okay, 8.5, all we're doing on this is just comparing different graphs. Okay, so we're going to compare different parts of graphs. So we only have 2 examples. Okay, your homework's going to be like really minimal. There's only 7 questions. Okay, so on number 1, it says a zebra's main predator is a lion. Lions can run at a speed of 53 feet per second over short distances. The graph at the right shows the speed of a zebra. We want to compare their speeds. So literally, all I want you to do is figure out how fast a lion is. Okay, so a lion runs how many feet per second. Okay, and when we write that line, that means per. So a lion runs how fast per second?
53.
53. It gave it to you. Okay, do I really have to make a graph to show 53 feet per second? No. Okay, then I want to interpret here a zebra can run how many feet per second? How do I figure out how many feet per second can a zebra run?
59.
Okay, we just said, how do you know it's 59? Because you looked at the graph, you interpreted the graph. That's all you have to do here. Okay, you're going to look at these points. This is time in seconds on the bottom. This is distance in feet on the side. This is marked right here. Okay, 1,59. 1 second, 59 feet. So a zebra can run 59 feet per second. That is all you have to do. We're just comparing them. Okay? You're just comparing them. Also, you need to know that these are both something called a direct variation. Okay? Direct variation basically means that it starts from 0, 0. Okay? So at 0 seconds, how far has the lion ran? 0 feet. At 0 seconds, how far has the zebra ran? 0 feet. Okay, so both of these represent a direct variation. Okay, so direct variation means that they start from 0, 0. Sorry. I'm getting there. Okay, a direct variation means that they start from 0, 0. You do need to know that because it is going to be on your homework today. Okay, direct variation means that they start from 0, 0, and that it's a line. Okay, all of these we're going to be dealing with lines though. So when it says compare, all I want you to do is just tell me what are the 2 speeds. Okay, so we just wrote those down. You don't have to tell me which one's faster. I don't want anything like that. I just want you to tell me what are their 2 speeds to compare. Number 2, it says the function m equals 140h, where m is the number of miles traveled in h hours, represents the distance traveled of the first Japanese high-speed train. The distance traveled of a high-speed train operating today in China is shown in the table. Assume the relationship between the 2 quantities is linear. So that means you can assume that it would make a straight line if you graph them. We want to figure out, compare the functions y-intercept and rate of change. What's another word for rate of change? Slope. Okay, rate of change, same thing as slope. So we want to find their y-intercept. What did I call y-intercept yesterday? I said B stands for what? Beginning. Okay, so I'm going to figure out where do they start at, what is their beginning, and what is their slope. So here, if the Japanese train, okay, the Japanese train, I'm looking at this one first. The Japanese train is at m equals 140h, okay? Where do you think it starts from? How far away is it when it starts? Okay, let's think about this. How far away is it when it starts? It's at 0, okay? If you haven't gone anywhere, if you haven't traveled anywhere, you are 0 miles from where you start. Okay, so the y-intercept is 0. Okay, Japanese train y-intercept equals 0. It starts at 0 from its starting point. Okay, that seems super simple, but people are going to mess that up really easily. Okay, what is its rate of change? What would you say is the slope here? How fast is it going per hour? 140, that's it. Okay, its rate of change or slope is equal to 140 and 140 what?
Hours. Miles per hour.
What would make sense there? Hours per mile or miles per hour? Right, so 140 miles per hour. Okay, so that's the Japanese train. Now, if we look at the train rate in China, okay, the train rate in China, where do you think it starts from? What would be the Chinese y-intercept? 0. Okay, it would only make sense that its y-intercept would be at 0. What do you think is its slope or rate of change? How can I figure that out? How would I figure out the slope or rate of change? Say it again.
Look at the chart.
You look at the chart. Okay? Figure out how long does it take. So for every 1 hour, it goes how far? What's the distance between 217 and 434? 217. You figure out how do you get from 217 to 434? You would add 217. Now, did you really have to do that?
Yes.
What's the easier way to do it? Go backwards, technically. If you go backwards, we would be at 0 hours. And to get from 0 miles to 217 miles, you would add 217. So you could also go backwards, okay? So the y-intercept is 0. The slope is 217 miles per hour. Okay, that's all I'm asking you to do there. Then it asks, if you ride each train for 5 hours, how far will you travel on each? So the Japanese train, how do you figure out how far you would travel? You multiply. You plug in miles is equal to 140h. What am I plugging in here? Am I plugging in for miles or for hours? For hours. So miles is equal to 140 multiplied by 5. Okay, you can work that out. So tell me, in 5 hours, how far would you go? If you multiply that out, you should get 700 miles. Now, how do you figure out how far you would go on the Chinese train? Anyone know? You can just keep adding 217, right? In 3 hours, you went 651. In 4 hours, how would you get from 651 to how far you go in 4 hours? What would you do? Add 217. What's 651 plus 217? 868. Almost. It's okay. Then to figure out how far you go in 5 hours, add another 217. So what's 868 plus 217? 1085. So you're just working it out. Okay, so the Chinese train, you would go 1085 miles in 5 hours. That's it. Okay, all we're doing today is comparing data from different places. So sometimes it's going to be in a sentence, sometimes it's going to be a chart, sometimes it's going to be an actual graph. Okay, all you're doing is just comparing functions. And these are functions because they're straight lines. Okay, do we have any questions on how I did that?
I can't see the bottom.
Bottom?